And now we go into the world of quality measurement. Next presenter will be Sandra Kugler. And Sandra has an extensive experience from different companies, from glass industry, and at the moment representing a company called Viprotron, working in the online quality measurement. So Sandra, over 20 years in the glass industry in several companies, Saint-Gobain, Arnold Glass, NSG, Flach Glass. So extensive experience coming into the stage, speaking about the topic Temper Scanner 5D, the new complete metrology scanner after furnace exit and its capabilities for furnace optimization and quality control.
So let's go. Hello. So nice to see you all here. Happy that people were joining this lesson, let's say, or this insight. I just wanted to take the opportunity today to show you a little bit more about our a new part to join in our product world, which was missing in the last years. So it is so it's the roller wave and etching solution, let's say, or the detection of the roller wave and etching. And we just completed and presented that on the GlassTech 2022. So just some words about the company itself. So we are working within this glass detection scanners since nearly 20 years, so next year it's 20 years. So one of the owners is also in the audience, Kai Vogel, and we are located in the south of Frankfurt am Main in Germany, and our production development, everything is in Germany. And so with the managing director being already in this kind of business before, we have more than 30 years of experience in this field. We are just focusing on to architectural glass, so like in your case, like, you know, IG production, tempering process, laminating process, processing itself, and so on. So nowadays we do have over 500 scanners all over the world in place. So just to my person, this was already said. Just to show you and to give you a short insight, to also show you where this was added, the new roller wave and etching solution. So we have nowadays 6 solutions, starting from the jumbo controller. So this is right before the glass cutting. So even if there's lucite on the glass, we can detect the errors to certain millimeters, so that even the raw material can also be checked. So which is good, because it's better checking it from the beginning than not having put any other value added on it and other processes on it. Then the quality scanner 3D is one of our this product itself, let's say. So this is where the company started also with. By the way, all the scanners you see, they are horizontal and vertical. So and all the other things, quality checker, so it's after IGU, and we can also measure holes and drill holes or countersunk holes and things like that. And the Eco Scanner is a small product which we can deliver all over the world, which has a wizard. We always had then, coming to today's discussion, we always had a solution around the tempering process. So we, in 2017, we developed an anisotropy measurement, and we also were the first in this field. And the haze, the haze part of it, which is around the tempering furnace, what we learned also this morning before with the haze. This is already, we did that from the beginning, to be honest, because in our first quality scanner, a part of this was the dark field, and the dark field always could see the haze. So having already this, and having already the glass defect recognition, let's say, we said, okay, now we have so many things around the furnace, we should give the baby a new name, and this is now the tempo scanner 5D. 5D for the channel is what I would like to introduce you now. So up to 5 inspection channels we do have in the tempo scanner. So first of all, as I said, from GlassTech 2022, we settled up the roller wave channel to see the edge kink and the roller waves. Then we can put the anisotropy channel inside. We could put also the haze channel inside and also the quality defect channels. So this all is modular and couldn't be put together. So as I said, so these channels are variable or modular and can be put together. And here in this way, so there are 3 channels which are looking on furnace-related issues, and there are 2 channels which are looking on glass-related issues. So also for the coating defects can be detected after the tempering process. So how does the new technology work? So the edge kink and the roller wave. Here on this, just to have a short information how it could look like also. This is a tempo scanner 4D, so this is without roller wave, but just to show you a little bit how the setting could be. So in this case, the blue ones are the cameras for the for the anisotropy, sorry, and the middle one is for the quality regarding the glass defects, and we are. What is special, or what is always be the case, we are working with line cameras. So we are looking really with line cameras, and we do have a setting of cameras and illumination, which is then helping us to find the defects. So we have different light sources. From the start, it's until 3.4 meter. There's different speeds of the conveyors. It's up to 50 millimeter per minute, and as I said, it's a modular design. And what is special also, it's easy to retrofit. So it can be used for sure always with new equipment, but it can be also retrofitted. So it's not a problem at all to put it into the standard spaces of the rollers, and we do not need any other colors of the rollers there. So just towards for the anisotropy. So as I said, so in this case, in this setting, it's the blue camera setting, let's say, and it's a precise measurement of the optical retardation. We do have a high resolution of up to 0.4 millimeter per pixel for the detailed analytics, and according to the standard which is now existing since last year in May, I think. For the haze, as I said, this is always since 2004 we are detecting haze. So there's a lot of experience to show the haze. We had the session also today about how to see haze, white haze, strong white haze or weak white haze. So there are special categories which can be defined, and then you can find out the haze effects. So regarding the new channel, so the roller wave scanner technology. So for sure, I also joined a session of Michael Elsner, who explained also this is the problem what you do not want, as a glass producer, do not want to have on a facade, or the facade planner do not want to have a certain distortion, a certain look and feel which is coming from the distortion, that everything is looking wavy because of the distortion of the glass, and the opposite building is shown, mirrored in the facade, and then it's looking like that. That's not what the architects or facade producers want to achieve. So this is kind of a problem then with the roller waves. So there's a precise measurement of roller wave edge kink with this channel. It can be then also visualized in 3D. Always it is possible to do the millidiopter, so the bow and the millimeter, so peak to valley. And it's a detailed quality definition recipes can be done. So usually also the glass customers, the customers want also to have a certain reporting, or for the anisotropy, you need to have a certain reporting to deliver in certain markets. So this is something which can be delivered per channel, and also for an internal purpose with more information, or for an external purpose. But it's something which the market really is looking for, because with what we heard also today, there's a lack of people being experienced enough to have a look on the furnace and not being perhaps able to do the fine-tuning. So it's really something important to have a quality control system for that. So how does it look like? How does it look like a little bit? So there's some light pattern, and as I said, the line camera. So there are several line scan camera boxes. So in total, it will be 4 cameras overall to get up to a width of 3.4. We do have a specific light pattern, which I explain in the next slides. The cameras are precisely aligned to the same position on this geometric structure. We do not need any gap or line or drive which is necessary, so it's just to see if there's space around. There's no special conveyor, and as I said, retrofitted, and we do not have any problems with minimized influence of roller unevenness. So how it looks like, as I said, there's a certain pattern where we are looking on. So we are working with with this line camera, and we are working then with a pattern of triangles, but not just the black triangles, also the white triangles. So the combination of both is important for the measurement. And also because we are looking on both, we have twice the information on the roller waves. So this is why it makes so special and also so precise, to be honest. As said, there's this pattern. So there's light from behind, and we are, like from the camera, is looking always on, let's say, this red line. On this one, it's not a real red line, it's just the alignment, how we put the camera on. When we have, for example, flat glass, so this is an example where we just took a flat glass piece, so a perfect flat glass, the camera looks straight into the middle of the triangle pattern, as I said, and when the glass moves, as you see, the triangle scan generates a picture with straight, thick, black and white lines, because it's just straight, so nothing happens, let's say. A line thickness always stays the same, and the measurement is something like 0 millidiopter. When we have a really bad glass, so in this case a lot of roller waves, and we are looking at the same spot, what will happen? It's just not anymore straight, because it's always going like that. And this is why we can measure also every 0.5 millimeter the actual roller wave values. And with this data, it's really super precise. And it's really a new approach according to what is available at the moment, and this is what I just told you. So there's also some use for sure for the operators at the tempering furnace. So the measurement is up to a resolution from up to 2 millidiopter. The measurement itself will be done every 0.5 millimeter. And the measurement resolution is also independent from the conveyor speed, which is really important. We do have this setting, this camera to light pattern arrangement is patented, and the measurement range is in between minus 550 millidiopter to plus 550 millidiopter. Glass thickness in between 2 and 20 millimeters. Glass types clear and tinted. Glass coatings, almost all hard or soft coatings, apart from anti-reflective coatings, which cannot be controlled for sure. So just to have a look on this pictures a little bit. So these are the measurements results of strong and weak optical distortion. So this is something also which can be movable, and the user interface can be also adapted to the need of the customer. So we had some customers also in our company already for that, and they were just saying, yeah, by the way, I need that and that and that, and it seems obviously that people needing for being able to handle it, and also depending on the know-how of the operator, different views and interfaces. So in this case, what we are doing, so usually you have a furnace bed with a lot of different pieces of glass, and then this furnace bed is going through the tempering process, through the quench, and then coming out. And after that, we are getting a picture of this furnace bed, and on this furnace bed you will see also there are some green and some red glass pieces. And on this side you can also see if it's a combination of all 5 channels. You can see, okay, anisotropy was fine, scratches bubble was fine, the coating defect was fine, but haze and roller wave and edge king in this case was not good. And then you can see from this one glass on the furnace bed, you will have the result which is shown here. And then you can see and analyze. And for sure, there are also reports for that, for the internal use, so where a lot of information are inside, and also for your customers, there are also some reports for that. So one other thing for sure, with the new technology and also seeing where we are, we did some, let's say some approvals to be sure that this is the right way. So we gave some samples to an institute who did a tactile measurement to see where is the deviation, and then we did some tests also with a roller wave setting in our company, and then we just having a look on the comparison of it, and we quite saw that we are very close on the tactile, but that's not yet the only thing. It's fine if it works once, but for sure we want to have also a repeatability. So it needs to be also in more than one measurement, always the same. So what we did also a comparison of the roller wave levels with 30 measurements. And if you see in the picture, there's always, so the blue one is our measurement, the black one is the tactile measurement, and you see also with the 30 measurements we are always close to the tactile measurement. So this is something which is really important also for the preciseness and also for the trust in the system and in the results we are getting there. So this was it. I hope I'm always a little bit fast. I hope I was not too fast.
That was perfect, Sandra.
But time is running, so 35 seconds still left.
You did perfect. Thank you for the great presentation.
Thank you.